What are some thoughts you have? Midline at -3, halfway in between your minimum and your maximum. Okay, so that makes sense. All the equations have a -3. When I look at that and envision the rest of it there, that looks like a negative cosine to me with an amplitude of 3. So do I have an equation that starts out -3? I actually have 2 of them. So I think it's going to be either B or D, because that's a negative cosine. What is the period of this guy? 6 pi. And how do we know it's 6 pi? Because here to here, minimum to maximum, half the period is 3 pi. So whatever number is right here, it has to divide 2 pi and give me 6 pi. So 2 pi divided by what is going to give me 6 pi? 1/3? No one said anything. Are you figuring that out on your own? Getting that on your own? All right, let's look at number 8. We haven't done any word problems, real life situations. So let's look at number 8. So hard, but it's really easy if you think about it. Anybody have a thought? See? The minimum number of daylight hours in San Diego is 9.6 hours. That's someone's thought. What do you think about that thought? Caitlin, thumbs up? Why? Why is that a good choice?
Because the midline is 12 and then the amplitude is 2.4.
The midline is 12. The amplitude is 2.4. So the max is going to be 12 plus 2.4, and the min is going to be 12 minus 2.4. So all the rest of that gobbledygook in that equation doesn't matter when we're talking about max and min, because max and min is vertical. Amplitude and midline are the vertical parts of the problem. That stuff in the middle is the horizontal part. Very, very good. Okay, go to page 3 and write me the equation for problem 15. And the equation will be like 2. You're gonna write a sine and a cosine for the picture in problem 15 on page 3. To figure out your amplitude. Be careful, amplitude is always positive. Alright, so the amplitude is 3. Everybody good with that? Amplitude is 3. Perfect. Were you able to figure out your midline? What's your midline? Y equals -1, very good. How about your period? Were you able to figure out what your period was? Labeled correctly, the period would be pi from 1/2 to 3/2. Does that make sense to you? I don't look at peak to peak. I can also look. That's the easiest place to look. I can look from here to here, but I have to figure out what that is. So I think your period is 1 pi. Are we okay with that, everyone? And that means your frequency is 1/5. Now, if you got all that, then you can fill in most of these equations. The number up front is going to be either 3 or -3 because that's the amplitude. The number at the end is going to be -1 because that's your vertical translation, the midline. If the period is pi, and it's supposed to be normally 2 pi, then didn't I divide by 2? That one's easy. Sometimes when they're like pi over 7, it's harder, but 2. If you're thinking of this as a cosine, I would start right here personally, but you wouldn't have to. So if it's a cosine, it's right side up, and it's shifted pi over 2 to the right. Now, I'm so lazy, I don't wanna figure out what that point is, so I'm gonna think of this as a sine curve. But if I do that, then it would have to be a negative sign. And I'm shifting 3 pi over 4. Again, many possible answers.
So if you don't change it like that, can you use 5 pi over 4 for the sine
Next
curve?
one, absolutely, and then that would be a positive sine curve. Alright, we all good with that? Okay, then here's what I want you to do. Sheet of paper, separate sheet of paper somewhere. I'm gonna have you sketch one. I'm gonna give you an equation. And there'll probably be some arithmetic involved, but that's okay. You can handle it. We're gonna sketch, 5/4 sine. Alright, and I'm gonna get you started, and then I'm gonna shut up and let you go, but there's something we have to talk about that I don't know if we've already talked about it. Do you notice anything different about that equation, Patrick? Exactly, and it has to be out. Okay, it has to be out. So the first thing you're gonna do before you start doing anything, the first thing you're gonna do is pull that 3 out. Now remember, factoring is division. So I'm basically dividing a 3 out of pi over 7. So won't that be pi over 21? When in doubt, check yourself. What's 3 times pi over 21? Pi over 7? Okay. And then that's what you're sketching. So give it a shot. See what you can do. And I will do it here in a minute. I'm gonna let you get started on that. Then don't look up here, because I'm going to do it up here while you're doing it out there.
bottom the amplitude side.
Okay.
And what if you
Just on that.
pause? Yeah. Right. I like mess up stuff. Yeah, so it would be right back. Yeah, no, wait, no, I what you're saying, yeah. The E is 14, it's 14 pi over 20. So if it starts at 1, you don't add 14 more, you only have 13 before it's over.
Alright, so conceptually, I think you all know what you're doing, at least I hope so. The arithmetic is just so out of control, unfortunately. So, did you figure out that your amplitude is 5/4 and your midline is 2? So, if this is my midline right here at 2, then my curve is gonna go up 1 1/4 and down 1 1/4 from that point. Would you agree with that? Now, I draw these lines in here, you do not need to. These are not required, you don't need them at all. But they're kind of giving the boundaries for my hill and my valley. So you okay with those? Now, it's a positive sine curve and it starts at pi over 21. So to keep my graph somewhat accurate, I went ahead, since I'm starting at pi over 21, I went ahead and did, this is 121, 221, 321, 421, and so on, until I got to my ending point, which isn't right. Oh no. Oh, did you see what I did? What did I do? I said my period was 1421s, which is right, but that isn't 14, I had it marked 1421s, but it's not 1421s, it's actually 1521s. Okay, well that actually makes it easier. So then my midpoint would be where? 1 plus 15 is 16. And half of that is 8. So 1, 2, 3, 4, 5, 6, 7, 8. All right, and then I need half, so that point should be right there. All right, and then I need to find the peak, the maximum, and that'll be halfway between 1 and 8. So that would be, this is all. So 121 and 821s makes 921s, and half of that would be 942s. So So this should be 9 pi over 42. Which reduces, doesn't it? What does that reduce to? 3/14. And then where's the bottom of my valley? Well, halfway in between 8 and 15. So 23/42s. And there we go. Can't believe I did that. Learn from my mistake. Period, you have to take into account where you're starting. So I started here and went 14/21s. Alright, yep.
Why would the period now have just been 2 pi over 3? Like, where do you get
It
the
was
7
2
from?
pi over 3.
Then where do you get the 7 from?
Well, I had to get a common denominator, because I'm starting at 1/21. So I got my common denominator and then forgot to add, but yeah, that's what I needed to do. I needed a common denominator to figure out where it went, right? All right, let's try another one, since I messed that one up. Let's do a cosine. How about -2 cosine? 1/2 x plus pi over 3 plus 1. Let's try that one. Then we'll move on in our notes, but let's get this, because next time we're gonna have a little quiz. You're gonna have to be able to do this. What's the first thing you're gonna do? Take out the 1/2, yeah. So factoring is division. So we're dividing out a 1/2. So wouldn't it just be 2 pi over 3? Go ahead and multiply it back. Does it work out? Does it distribute back to give you what you want? start your cosine at negative 2 pi over 3. And remember, cosines start either at a max or min, so this is upside down, so it started down here in the minimum. And then the next minimum would be 1 period later. Did you get your period to be 4 pi? 2 pi divided by a half, so 4 pi, which I went ahead and made 12 thirds because I need to know where that last, or where that next minimum is, and it will be 12 thirds after the first one, so 10 thirds out there. And then halfway in between negative 2 and 10, which would be 4, negative 2 plus 10 is 8, half of that's 4. That's my maximum. And then halfway in between negative 2 and 4, which is 1, is my, we call them the 0, where we cross our midline. And then 4 and 10, 14, halfway in between there is 7. So these labels aren't really being used. I use them to space out my grid, but there it is. All right, do we feel relatively confident that we can do that tomorrow? Or whenever I see you again?
Why is it negative 2 pi over 3 instead of just 2 pi over 3?
Because remember that when you add to x, it shifts left. Minus would shift right. Everybody good? Okay. All right, let's get our notes back out then. It's still in your same notes packet. We have, I think 3-7 might be the last one, but it's there, 3-7. This is a lot of stuff we've already talked about, so you'll be fine. Example 1. What is the period of that thing? Yeah, guys, yeah, don't make it hard. The period's 2. How do we know that? Well, I don't know how you think about it, but 1 hill and 1 valley is 2 units wide total. So that's the period. All right. Example 2. Which of the following could represent the constant C? Now C is the phase shift. So there are many, many answers. But of the options he gave you, what could be C? Now look carefully at his equation there. Pi over 2 is 1 thought. Because if C were pi over 2, that would shift you pi over 2 to the left. And is that a cosine curve starting at negative pi over 2? Yeah, that would be great. That would be absolutely great. Are we okay with that? All right, here we go. Now we got a yo-yo. Let's read this. We need to write an equation for the situation. This might take a minute. Let's read it. Anyone have an idea? This one's a little bit tricky. Charlie?
Well, I first started with like, the sentence really caught my attention was, at times t equals 5 seconds, the yo-yo has completed 20 rotations.
Okay, that's an important thing to know,
That's really important.
because what is that gonna tell us, Charlie?
Well, that tells us the frequency that every time at a t, or like basically every 1 second, the yo-yo has completed 4 rotations.
I love it, that is frequency.
That's the frequency.
So the frequency is 4. Because in 1 second, you get 4 cycles. And if the frequency is 4, then we know the period is 1/4. And that is an essential thing to know if you're gonna write the equation, right? Okay, where did you go from there? Beautiful.
Then I noticed that, by the unit circle, it's 2 pi, so if you just did 2 pi divided by the period, you would get what was in the equation. So 2 pi divided by 1/4 is 8 pi, and D has 8 pi.
Well, you mean whatever the coefficient,
Right.
this is gonna be 8 pi t
Yeah.
here? All right. And it's a sine equation. And in one option with a pi there, so it must be the last one. Right, nicely done, Charlie. Did you, like Charlie, notice that the only thing different on those 4 equations was the period? So all Charlie did was find the period and then figure out which of those worked. Nice work. All right, example 4, here we go. The clock on the wall again. Have you figured it out? In the equation, A is gonna be the amplitude, right? And D is gonna be the midline. And don't we know the high and the low? What's the difference between the high and the low? 18. So won't the amplitude have to be half of that? So A is 9. And then if the high point's at 70 and the low point's at 52, the midline has to be in between there, right in the middle in there. And so I guess either 9 below 70 or 9 above 52, either way. 61? Your midline was 61? Is that okay? All right, example 5. Yeah, you,
Yeah.
what's your
For
idea?
example 5,
Yeah.
I said C by, subtracting the, amplitude from the midline.
Okay,
A
so,
from
so you looked at your equation,
B.
and you said that the maximum, or no, excuse me, the minimum, since the amplitude is 25.7 and the midline is 61.2. So here's 61.2, and we're going up and down this much, right? So you said the minimum is gonna be at 61.2 minus 25.7, and is that 35.5?
Yeah.
All right. What do the rest of you think? Is he right? Yeah. Are there any others that could be right? Is the maximum at 61.2? No. That would actually be not the average maximum, but the average temperature would be right up in the midline. So that's not it. Yep, I think you're right. I think you're right. All right, let's get our calculators out. We're gonna do a little regression now. We haven't done any trigonometric regressions yet. So let's get our calculator out. And let's put this data in. You might not have enough time to get it done, but let's at least get the data in, so here we go. Did you find your sign regression in your list? Oh, shoot, I just lost it. Did you come up with an equation? What's it look like? Y equals? Now, when your calculator does it, it doesn't factor out the B, but, and that's fine. You need to do that in order to graph it. But what did you come up with? Y equals? Let's make it an 8. We're gonna round it 1,000. So 3.118 sine parentheses 569, we'll go to 1,000, is that right? 569. X was, wait a minute, plus 0.921 plus 8.215, does that look about right to everybody? All right, we're gonna continue this conversation next time because we gotta be careful of using the equation in that point. But anyhow, we'll finish this problem next time.
It's 8.2 and 5.
Okay, remember, regression is an approximation. So the kids are going to get it exactly. So you're going to, according to the model, according to the actual data, you might be able to do it. Yeah, you have great data. So it says, what is the maximum predicted by the model? So then you'll use your equation. Yeah.
And with the equation,
Nothing that's there. Right, let's look at it next time.